Hello, we are going to discuss about indices. You can't perform indices without knowing the rules. First one, when you have a power n, this means that is a times a itself n times. What this means? For example, if you have a power 2, this is a times itself. When you have 2 power 4, this will be 2 times itself 4 times. 2 times 2 times 2 times 2, 4 times 1, 2, 3, 4. This is how we perform the indices. Here, we will consider A as the base of index. Then this is we read that A to the power of n. If I write 2 power 5, this is 2 to the power of 5, or simply 2 power 5. Knowing this property, it will help us now to perform a big number of indices. Second property. When now you have an times am, this means the same as you copy the base and you add powers. It means that to multiply indices of same base, we copy the base and add the powers. We can have now examples to understand better this property. Examples. Simplify. This one, we know the distributive property when you have A into B plus C. To expand this, you take A times B, you get AB. A times C, it will be A times C. Using that property and including this index, I will say it will be x power 2 times xy plus x power 2 times x power 2. Here, x will multiply x. As they are same base, I will copy x. Then, if you write x, it is x power 1. This will be 2 plus 1. Then I copy y. Plus x squared times x squared. I'll copy the base because they are the same base x. Then I add the powers. The final answer will be x cubed y plus x power 4. You see, to multiply here, I used this property that same base, I'll copy the base and I add the powers. This number 2. Number 2. Two power 4 times 2 power 5. This 2 power 4 itself is 2 times 2 times 2 times 2, 4 times by using the first property. 2 power 5, it is 2 times 2 times 2 times 2 times 2, 5 times. When now you combine them, 2 power 4 times 2 power 5, it will be 2 4 times 2 5 times 1 2 3 4 5. When you count in the total, it is 1 2 3 4 5 6 7 8 9. It becomes 2 power 9, which is meeting the other property. We say that to multiply the indices of with the same power, same base, you copy the base and you add the powers. 5. This is 2 power 9. You see, using the rules, calculations becomes very simple than developing all. This is the property number 2. We can put property of the rule number 3. When you have h m dividing by a power n, this can be written simply, okay, this can be written as a power m over a power n. This means the same. It's you copy the base and now you subtract the powers. M minus n. If you are dividing the indices of same base, you copy the base and subtract the base. Here there are two cases. You can find the power of denominator bigger than power of numerator, or the power of numerator bigger than the power of denominator. I want to combine this property in one example with property 4. When you have a power, a negative power, this will be the same as a over a power n, 1 over a power n. This is changing an index into positive powers. Normally, it is better to write a number in positive power. If you get a negative power, you apply this property to get the positive power. This one, it can be also used in on another side. You can have 1 over a power, a negative power. How do we do to convert this one in a positive power? This one is on denominator. It changes the position from denominator to numerator and it becomes positive power. Simply, it is a power n. You see, we don't change the sign of the base, but we change the sign of the power. We can now combine these two properties in one example. Let's have an example. Simplify 2 power 6, 2 power 4, 2 power 4, 2 power 6, 3 power 7 over 3 power 10, 3 power 4 over 3 power 2. Now, we can perform these two numbers. We always leave the answer in a positive power. There are two ways. If I have 2 power 6 over 2 power 4, there are people who prefer to develop and they simplify. These 2 power 6, using the first property we studied, it is 2 times 2 times 2 times 2 times 2, 6 times 1, 2, 3, 4, 5, 6. This is 2 times 2 times 2 times 2, 4 times. And you simplify, you know, this is 1, 1, 1, 1, 1, 1, 1, 1. Then 1 times 1 times 1 times 1 times 2 times 2, you get 2 power 2 over 1, which is finally 2 power 2. When you use the property that 2 power 6 over 2 power 4, we copy the base and we subtract powers. You take 6 minus 4 and you get 2 power 2. You see, using the rule, steps become very short. But there are people who prefer to simplify. You can know even this way. Number 2. Number 2, when you have 2 power 4 dividing by 2 power 6, in the first method, I will take 2 power times 2 times 2 times 2 and 2 times 2 times 2 times 2 times 2, 6 times 1, 2, 3, 4, 5, 6. By simplifying, this is 1 over 1, 1 over 1, 1 over 1, 1 over 1. You see, above, I will get 1 times 1 times 1 times 1 is 1. This is 1 times 1 times 1 times 2 times 2 is 2 times 2, which is finally 1 over 2 power 2. Using the rule now, if you want to get the final answer in positive power, you take a rule to move small power to big power. Move the small power to big power. This theorem will help us to remain with positive powers. What does it mean? 2 power 4 over 2 power 6. When this numerator moves to down to denominator, I'll remain with 1. And it will be 2 power 6. As it was the numerator, when you put it on denominator, it have to change the sign of the power. It was plus 4, it becomes minus 4. And you get 2 power 6 minus 4 is 2. You see, this answer, it is already in positive powers. But it is also possible to take that. Remember, the property is A over M over AN is AM minus N. You see, the property is moving the denominator power to numerator. Still, you can use this power. This formula is 2 power 4 over 2 power 6, here you will get 4 minus 6, which is 2 power negative 2. Now, this is a negative power. You can now apply the third property, because it's better to leave the answer in positive power. It becomes 2 power 2. This power, when it moves on denominator, becomes positive. You see, they will be the same, but this is very short to consider that small power moves to big power. It is the one which is short and give the answer faster than that one. See, when you have 3 power 7 over 3 power 10, simply this will be 1 over 3 power 10 minus 7, which is 3 power 3. Then in the last, 3 power 4 over 3 power 2. 2 is smaller than 4. I'll move it on the numerator. I get 4 minus 2 over 1, which is 3 power 2. Now, many students get challenged now when they have variables. For example, they ask you to simplify x squared y 40 over x power 6 y power 2 and t. Here, we simplify first of all same letters, like terms. I can take x squared over x power 6, and as the denominator has big power, I move the numerator power to denominator. I get 1 over 6 minus 2, which is 1 over x power 4. For x, I have 1 over 4. You see, x power 4 is on denominator. Then I can take the y's, y power 4 over y power 2. Denominator power is smaller than the numerator power. I'll move denominator to numerator. That is 4 minus 2 over 1, which becomes y power 2. Lastly, t and t will cancel. They are the same. If they are the same, it's like 2 over 2. I cancel them. I get 1 over 1, which is 1. Then finally, I combine my answers. The final answer of my equation it will be, for x I got 1 over x power 4. For y I got y on numerator, then t it is 1. By multiplying, I get y power 2 over x power 4 as my final answer. The last property of today I want to share with you is now property number 4, that a power 0 is always equals to 1. Any number you have power 0, it will be 1. I want to make just a small proof to know. We want to prove how this is, to know where it's coming from. To prove this one, I will use the previous property. If I have a power m over a power n, this is a m minus n. Let's use an example. I have to take this, it means that m minus n equals to 0. If I have a power 0, it means that m minus n is equal to 0. When m minus n equals to 0, it is when m equals to n. I'm going to take now two powers, like a power 4 over a power 4. This, okay, I'm going to take a power m. Let's take a power m minus n, where m equals to n. It is like 4 minus 4. By developing this is the same as a power 4 times a power negative 4. Then the negative power, we know how to change into positive power. By changing it into positive power, you see, I will get a power 4 times 1 over a power 4, which gives a power 4 over a power 4. This is a times a times a times a 4 times a times a times a times a 4 times. By simplifying one another, I finally get 1 times 1 times 1 times 1 is 1 over 1, which is 1. Here, it means that wherever you have a power 0, it is always 1. Example, xy power 4, t power 7 power 0, the answer will be 1. 1 million power 0, the answer is 1. This is a very important property. Whenever you have anything to power 0, it will be 1. Now, these are 4 first properties. We will continue to give you more until we get all properties that can help us to simplify indices. Thank you for attending. Continue watching and subscribe, share our videos to everywhere. Thank you.